So problem 5.4, reading it about the monk going to the monastery and as you have to be in the same place at the same time, it can definitely get confusing just reading it and trying to think about, well, wait, does he have to? The trick to this problem is drawing a graph. This chapter is on graphing. Who'd have thought the trick was drawing a graph, right? So if you draw a decent graph, it actually makes it really easy. So I drew a graph. Okay, here we'll say he starts off here at the seaside monastery, so that's position 0 or whatever, right? We'll put that to origin, the seaside monastery, and here's the mountain. So you go, this is distance and this is time, right? So I started off at 5 a.m. to 3 p.m., did it by hours here. So we're marking distance versus time. He gets to the mountain monastery at right there at 11, so I'll put a dot right up here at 11. And he didn't have to walk at a constant speed. He could change his speed, he could go faster or slower. I'm just going to connect it with a straight line, but it could be a wiggly line, doesn't matter because you never walk at a perfectly constant speed the whole time, but whatever. So let's just do that and we'll see why it doesn't matter. Okay, now the next morning, he stays there, right? I could say draw it here, he stays there. But the next morning he leaves at 5 a.m. and goes the other way. So I'm going to just draw that line starting at 5 a.m. again. It's the next morning, but who cares? We can still start at 5 a.m. So now he's here at 5 a.m. Okay, so we'll put him right there. And now he walks back and he gets there at 11, which is right there. Now, let's say again he doesn't walk in a straight line, which means his speed is all over the place. The slope can be anything. He's never going backwards. Well, I don't know, maybe he did even go backwards. So he's going down this way, and it's a negative slope. We'll say it's a negative direction. So we just got to connect it to that dot. So again, it doesn't have to be a straight line. It can be anything like this. But it's got to be, okay, now that's impossible, right? That can't be perfectly steep there. So I'll try to make it semi-possible. So it's kind of like this. Yeah, I'll just kind of straight line at the end. Okay, so he walks back down. He dawdles. He takes his time here, not as fast. Goes really fast, not as fast. Goes fast towards the end. Okay, notice we have to cross the black line. There is no way to get down to the bottom without crossing the black line. And where those two intersect, right there, they're at the exact same place, wherever that is, you know, like halfway up the mountain or something. They're at the exact same place at the same time. They're both there at 8, whatever. No matter how I drew the black line and the blue line, they're going to have to cross. So, yes, they have to be at least once, and really only once, right? How can you cross the line twice unless you go backwards, which we'll assume that's cheating. No going backwards. They're at one point and only once, those lines are going to cross each other, and they have to be the same place at the same time. If they were both straight lines, then it'll be halfway, right? Halfway between 5 and 11, which is like 8 o'clock, 3 hours on either side. It'd be at 8 o'clock. But they don't have to be straight lines. They can walk fast and walk slow. All right, so that's part A. Now, part B says, suppose the monk walked faster in the second day and gets back at 9 a.m. Okay, so let me do that in green. So he gets back here at 9 a.m. So I draw a line from here, and again, no matter how I draw the line, I have to cross the black line, right? It'll probably be earlier in the morning. Right now it's like 7:30 or something. But now it's 7:30. They're going to be in the same place, a different place probably, because it'll be further closer to the sea because this guy is walking faster now. It has to be, right? And again, only once, unless you go backwards, which we're going to assume isn't the case. This problem is real easy if you draw a graph, right? So clearly, at one place they cross. Now, the last part says, suppose a monk starts later and gets back at 3 p.m. Okay, so now the monk starts at 10, I think is what he says, at 10 a.m. So let's do that in, what do they call it? I have the pink color here. Hopefully you can see it. So at 10 a.m. the monk starts, so we'll put a dot right here at 10 a.m. And and now he walks till 3 p.m., right? So it gets back here at 3 p.m. Okay, so now does he have to cross it? Make sure I get this right. Suppose the monk started at 10 a.m. and reached the seaside monastery at 3 p.m. What is your answer now? So, starts here, starts there. So, is there any way unless he stays in the same place and then heads down, which he said he doesn't. He starts walking, so he can't stay in the same place. So now I got to go to this 3 line, and again, no matter how I get there, I have to cross that black line. You just have to cross the black line. The only way to not cross the black line is to start after 11, okay? And then they won't be in the same place. But of course they won't, because its times don't match. So even then, if you start later, they will be in the same place at the same time. So here, it would be at around 10:30 or something, right? At 10:30, they're at the same place at the same time as they were the day before. Okay, so that's how you do this problem. Really easy if you draw a graph and then just keep using the same times and drawing the graphs on top of each other. So all 3 of them is the same answer. They always will be at least one place, and really only one place at the same time, no matter how they start. Okay, hope that helps. Yep.